Hello folks. I've done quite a bit of testing with the Chicago Electric 125 amp flux core welder from Harbor Freight, but today I wanted to do a few quick tests with different levels of preheat to see how much difference it makes. I also wanted to see how practical it is to use a basic propane or mapp gas torch for preheating versus an oxy-fuel torch such as an oxyacetylene or oxypropane. Two reasons for this. First, many people don't have a set of oxyacetylene torches, and anyone hoping to get more out of their $100 welder probably isn't looking to buy a $300 set of torches to do it. But secondly, I don't have a set of oxyacetylene torches. This is the welder I'll be using. It is the 125 amp version, but as I've said before, it is the same as the 90 amp version. They just put a different number on the box now. Both are rated, at what they call a rated output of 90 amps and 125 amp max. They just put the 125 on the box now instead of 90. Also, this is not the one that I converted to DC. This welder is still stock with AC output. Since this welder gets okay penetration on 1/8 inch material without a preheat, I'll be using 3/16 inch material today. I have 4 T-joints tacked up, and I'll cut and etch each after welding. First, I'll weld up a control with no preheating. Then I plan to test 500 degrees, somewhere around 750 or so, and then the fourth I'll just get as hot as I can reasonably get it with my mapp gas torch. For the non-preheated T-joint, you can see little to no penetration, which wasn't unexpected for me and won't be too surprising for anyone who has watched any of my other videos with this welder. But I wanted to do it again today so that I could ensure the settings on the welder were exactly the same for all the joints, because I wanted to see how much difference the preheat makes with no other changes. It may be a bit boring, but I wanted to show at least the first preheat full and uncut because I want people to have an understanding of what it's actually like to preheat even a small piece of 3/16 material like this with a torch like this. The table is drawing some heat from the piece, but it's not too bad because the table is kind of covered in slag dust and spatter BBs, plus the tabletop is very thin. I could surround the part with fire bricks and insulate it and get it red hot with a mapp gas torch, but for most projects that's not going to be practical or even possible, and most times you'll be trying to heat up a larger piece of metal than this too. So I just figured that, this real world situation good enough, and this is how I'm doing it. Once I got it heated up, I got set up to weld, and I double checked the temp before I started welding and just heated it up just a little bit more again just to confirm that it was at 500 degrees when I started welding. you can see almost no difference in penetration with the part preheated to 500 degrees. And since 500 degrees gave almost no change, I decided to go right to 1000 for the next test. I'm not going to show this whole preheat because it's just more of the same, not too exciting, but I did end up writing 900-ish on the piece because I checked it just before starting and it was around 900, and it was really hard to keep it around 1000 because the torch could just barely get it there. This joint did show a bit of improvement. There is still very little penetration, but it seems that it is starting to burn in just a little bit. The bead is also laying flatter. It still has a crowned profile, but not as bad as the other two. The 900 degree preheat definitely helped, but it's still not a dramatic difference. The welder that I converted to DC did far better than this with no preheat. For the last joint, I just kept heating and heating and heating it with my torch. I even stood it on its side to try and minimize heat loss to the table, although I think that created airflow over the part from a kind of a chimney effect, and it actually was worse, so I put it back down. And with this torch, I just couldn't get it above 1050 degrees or so, and at that temp it was cooling off so fast when I stopped heating it that it really wasn't going to end up meaningfully hotter than the 900 degree test, so I just didn't even bother doing another one. So what's the takeaway for me on this test? First, it's no surprise that preheating can definitely help you get more out of a welder like this on thicker material. But it seems that you realistically need 1000 degrees Fahrenheit or higher to make a meaningful difference. Because of the temp needed, a small propane or mapp gas torch like this really doesn't cut it. If you need to weld a crack-sensitive material that you need to preheat first, one of these torches would be fine. But getting anything more than a very small piece of 3/16 material above 1000 degrees Fahrenheit in a real-world situation is going to be pretty difficult and time-consuming. And any less than that temp, and you're just not really getting a meaningful performance benefit. So to get a meaningful performance improvement by preheating, you're really going to need an oxy-fuel torch to do it properly. So that's it for now. Hopefully that was helpful. If you have any questions or specific tests you'd like me to try, let me know. As always, thank you for watching. Take care.